Okay, so on slide 14 here, so I am going to talk about the relationship between differentiability and continuity. So one thing that you should know is the differentiability. This thing implies continuity. So we're going to have a theorem say that for any real value function f and any point a in the domain, if our function f is differentiable at x equal to a, then the function is continuous at x equal to a. So just keep in mind that, well, differentiable, this thing implies continuous. But if you have the function that is continuous, well, it is not guaranteed that the function is differentiable. For example, if you have fx equal to square root x, so you can see that the function fx equal to square root x have the graph like this, right? This is a graph of fx equal to absolute x. And then you can see that the function here, this is continuous at x equal to 0. But this is not differentiable at x equal to 0. Well, you can try compute the left-hand derivative and the right-hand derivative of the function f, x equal to absolute x, and then you will see that the left-hand limit and the right-hand limit, they are not equal to each other. That means the function is not differentiable. So to prove this thing, I mean, the proof is easy, so I am going to sketch it for you. So, well, if we know that the function f is differentiable, then f prime a, right? I mean, at x equal to a, then f prime a exists, right? And then after that, if you consider the quantity limit of fx minus fa, where x go to a, if you simplify this thing a little bit, so you're gonna get limit of fx minus fa, and then you multiply x minus a over x minus a like this. So you just multiply by number 1, which is x minus a over x minus a. And then once you group it, you can see that this thing is going to be just f prime a, right? And well, that thing is going to be f prime a. And then when you use the limit law, so it's gonna get to the point that we have x f prime a multiply limit of x minus a, where x go to a, right? And then we have f prime a multiply limit of x minus a, where x go to a, which is 0. So that means this is 0. So when we have this statement, limit of fx minus fa, where x go to a equal to 0, that means limit of fx where x go to a equal to fa, which means the function is continuous at x equal to a. So this is the proof, which is optional for you, but it is easy enough to show you the proof for this theorem. So what I want you to memorize is that when we have differentiable function, it implies that the function is also continuous, but the converse is not true. So sometimes we need to use this condition to solve the problem. So we're gonna do an example. So given the function fx equal to x squared, where x less than 3, and fx equal to ax plus b, where x is greater than or equal to 3. And now I suppose that f prime 3 exists. So I want you to find the value of a and b. This is O exams. And you know what? It looks easy, but I would say that more than half of you are gonna miss this question. Well, because this question looks pretty simple, but once you start working on it, you're gonna see that we need to use some trick. And yeah, let's get started and then you see the trick. So example 37. So because the question said that f prime 3 exists, that means f is differentiable at x equal to 3, right? Well, when f is differentiable at x equal to 3, that means we're gonna have f prime 3. And then this thing is also equal to the left hand derivative at x equal to 3, and also equal to the right hand derivative at x equal to 3. Well, the reason why I mentioned left hand and right hand derivative, this is because I look at my function and then I see that, hey, man, when x less than 3, I use the function that I label in green. And then when x greater than 3, I use the function that I label in yellow. So that means on the left hand side and right hand side of the point x equal to 3, well, I need to consider different functions. So that's why I mentioned left hand and right hand derivative. So let's compute the left hand derivative first. So I have f prime, the left hand derivative f prime 3 minus here. So by definition, this is going to be limit of fx minus f3 over x minus 3, where x go to 3 from the left. And well, once you look at the function, because this is x approach 3 from the left, so I am going to use the function x squared. So I'm going to replace my fx by x squared, and then f3. So we're gonna compute f3 first. So f3 is a times 3 plus b. So this is going to be 3a plus b. And then I have 3a plus b here. And then over x minus 3. So at this point, you cannot simplify more. So let's stop here. And then let's look at on another side. So I am going to look at the right hand derivative of f at x equal to 3. So I'm going to compute limit of fx minus f3 over x minus 3, where x go to 3 from the right. So this is a definition of derivatives. And then from this equation, so fx, I have to use ax plus b. And then f3 is also 3a plus b, right? And then over x minus 3. So the right hand derivative looks easier because you can cancel your b, right? And then you can also factoring. So you can pull out your a here, and then you have x minus 3, right? And then your x minus 3 gonna cancel. And then once you compute limit of the constant a, where x go to 3 from the right, so you still get a, right? So that means, hey, I know that the right hand derivative, I get a. But the left hand derivative, you can see that we have a problem here because we get stuck here because we don't know the value of a and b here, or 3a plus b yet. So many of you, I mean, if this show up on the exam, many of you are gonna get stuck here, and then you're gonna just let the thing that I box it in red equal to a, and then you're trying to solve it, and then you cannot solve it. So the trick for this question is that, well, this is not enough to solve this problem. Well, because we know that, this is a trick, because we know that f is differentiable at x equal to 3. it means that function f is also continuous at x equal to 3. We just learned in the first 5 minutes of this lecture that, hey, differentiability implies continuity. So that means if I have differentiable function, the function must be continuous too. So now I have more condition that I can play. So I'm gonna say, hey, I know that function is continuous at x equal to 3. So because f is continuous at x equal to 3, so I have limit of fx where x go to 3 from the left is equal to limit of fx where x go to 3 from the right, and also equal to f3, right? Because this is the definition of continuous function, right? Because, well, if you want to say the function is continuous at x equal to 3, so that means f3 must equal to limit of fx where x go to 3. And then, well, let's consider the function again. So we know that limit of fx where x go to 3 from the left, so you just have to look at the function again. So when x go to 3 from the left, you use x squared, right? You use the function x squared. So that means here you're gonna have limit of x squared where x go to 3 from the left, which is 9. Good. And then you have limit from the right, which is you use a function ax plus b, right? And then this thing you have 3a plus b. So because you know that they are equal to each other, so here you have more information that 3a plus b equal to 9. And once you use the continuity to solve that 3a plus b equal to 9, you can just use this thing to plug in back into your original thing that you're trying to solve. So if you go back to our original question, you can see that I got stuck because I don't know the value of 3a plus b here, right? But because I use the continuous property, so I know that 3a plus b equal to 9. Does it make sense? Because this 3a plus b is equal to 9. This is because of the continuity, right? And then after that you can, well, I give a space here. So after that you can factor, and then you're gonna get x plus 3. And then after that you have 6 here because you plug in x equal to 3. So that means now you compute the left-hand derivative and then you get 6. And then on the right-hand derivative, you get a. So they must equal to each other. So that means a equal to 6. So a equal to 6, right? And that means b equal to negative 3. B equal to, okay, let's go slow. So a equal to 6, that means 3 times 6 plus b equal to 9. And that means 18 plus b equal to 9. That means b equal to negative 9. Right? So your answer is going to be a equal to 6 and b equal to negative 9. We're going to move to the next thing, which is called the chain rule. And this is the one of the most important tools that we're going to use to compute derivatives. All right, so I am going to look at the chain rule now. So the statement of the chain rule is here. So if f and g are both differentiable and you have the composite function f or g, then you can differentiate the composite function by using this formula. So this formula says that if you want to compute the derivative of the composite function f or g. Then you can compute by just compute the derivative of f at gx first, and then you multiply g prime x. That is the statement of the chain rule. So, well, if you are a math person, you can understand this notation clearly. That is fine. But for those of you who are not, familiar with this notation, well, the chain rule says that if you want to differentiate, you have to differentiate inner function as well. So if you look at the visualization that I have here, so let's suppose that you have the function fx, right, raised to the n power here. If I want to differentiate this thing, you can treat your fx as your inner function, and then you have your outer function, which is something raised to the n power. And then when you differentiate, you just differentiate outer function first, which is n times fx raised to the n minus 1. And then the one that I highlight in green now, fx here, this is called the inner function. And then you can just differentiate inner function after that. Does it make sense? This is how you use the chain rule. So for example, if I say I want to differentiate, I have fx equal to 3x plus 1 to the 10 power, for example. Well, basically we do not want to expand the 10 power because it's, time consuming. So what we want is, we want to differentiate this thing by using the chain rule. By using the chain rule, I am going to look at my function 3x plus 1 as an inner function. And then what I am going to do is, I am going to treat my function as something that I box in red, raised to the 10 power. So I have 10 times something that I box in red, raised to the 10 minus 1 power. And then I have to differentiate my inner function that I box in red again, right? So that means the thing that I box in red is 3x plus 1, right? So at the end, you're gonna have 10 times 3x plus 1 to the 9 power, and then differentiate 3x plus 1 with respect to x. So you get 3 by using the formula, and then you get 30 times 3x plus 1 to the 9 power. Make sense? So I know that some of you have seen this thing before, and for those of you who have not seen this thing before, you need to practice a lot, because this is what we are going to use for the whole calculus 1 and 2 series. So when I ask you to differentiate, no one gonna expand. So everyone gonna use the chain rule, because this is a lot easier. And then, well, if you keep repeating this thing, so you're gonna absorb the technique again and again, and at the end you're gonna do this thing faster and faster, and then, well, you will see that the chain rule is so simple. So another formula for the chain rule is this thing. If you wanna compute dy by dx, you can view the chain rule as dy by du and multiply du by dx, because you can act like the du cancel here, right? And then so you're gonna get dy by dx. So this is another visualization that you can look at the chain rule in Leibniz notation. So we're gonna do some examples now to get you more comfortable with chain rule. All right, so let's look at another example here. So this is the easy question. I mean, this is considered as an easy question if it show up on the exam. So let y equal to the cube root of u minus u, and u equal to x squared plus 2 over 2x minus 5. I want to use the chain rule to find dy by dx. So I have a question from students. So Puvin asks that from now on, can we use the chain rule to differentiate? Yes. So from now on, if I ask you to differentiate, you can use the chain rule now. So even in homework too, you don't have to expand anything. I mean, if you can use the chain rule, please use the chain rule because it's a lot easier. So I am going to show you how to do this thing. So we're going to start by y equal to u to the 1/3, right, minus u. This is our first equation. The second one is u equal to x squared plus 2 over 2x minus 5. And if I want to compute dy by dx, so by using the Leibniz notation, so I can compute dy by du first, and then multiply du by dx, right? Because this is, if you think of this thing as a picture, you're gonna see that you have a function y, right? Which is a function, y, which is a function of u, and you have u, which is a function of x, right? So when you want to differentiate y with respect to x, so you can differentiate via u. This is how we think about the chain rule, and this is why we call it the chain rule. So we're gonna differentiate y with respect to u first. So from what I just circled here, so I am going to differentiate this thing. So we get 1/3 times u to the minus 2/3, right? That is how I differentiate y with respect to u, and then minus 1, right? Because I differentiate u to the 1/3, so I get 1/3 times u to the minus 2/3, and then differentiate u, you get 1. So you can use the formula here easily, and then after that, we're gonna differentiate u with respect to x. You have no choice here because this is our quotient, right? So you have quotient function, so you have to use the quotient rule. So I'm going to differentiate this thing. So I differentiate the fraction. So I need to use the low d high minus high d low over low square. So this is going to be 2x minus 5. And then I need to differentiate x squared plus 2 minus, so I am trying to go slow for you. So x squared plus 2, and then you differentiate 2x minus 5. If you can go faster than me, that is very good. Some of you are gonna say that you can differentiate x squared plus 2 easily. So can I just say this is 2x? You can. So if you feel like this thing that I just boxed in purple here, you say that, hey, Ajahn, I can differentiate this thing easily. You can just say this thing 2x, fine. But I go slow now here because this is our first example. So 1/3 u to the negative 2/3 minus 1. And then I am going to differentiate that thing. So I have 2x minus 5 times 2x minus x squared plus 2 times 2 over 2x minus 5 squared. Well, this is good enough for your answer for dy by dx. But what we want is we want dy by dx at x equal to 1. So that means you have to plug in x equal to 1 here. You're going to plug in everything that x equal to 1. Well, you have u here. Well, you have to figure out when x equal to 1, what is the value of u? So when x equal to 1, you have u equal to x squared plus 2 over 2x plus 5, right? So you can plug in number 1 here. So that means your function, your u here gonna be negative 1, right? Because it's gonna be 3 over minus 3, so which is negative 1. And then after that, if you plug in everything into the function here, so it's gonna take time to compute this thing, right? 2 minus 5 squared. So I will let you calculate this thing by yourself, but the answer gonna be 8/9. I already did it. So I just gave you the answer, but the rest of the work is simple. You just need to calculate this thing. So you get 8/9. All right, so that is how you use the chain rule to find the derivatives. So I hope this is not too hard for you because this is the basic question. So this is considered as the basic question on the exam. So this is not hard at all. All right, so let's move to another question. So example 39, so this is also the basic question. Some of you are gonna, when I just change the question to the notation question, some of you are gonna get stuck and, Ajahn, I don't know how to do this because you do not understand the notation. So I would say that the hardest part for chain rule is you need to understand the notation, because sometimes the notation that we give you is a little bit weird. You have to figure out by yourself what is given. So example 39. So I have the function h, which is the composite function between f and g. And I have function p, which is the composite function between g and f. And here, I want you to compute h prime at 2 and h prime at 3, p prime at 0, and p prime at 4. All right, so let's do this thing together. So I start from h prime at 2. So what does it mean by h prime at 2? So that means you want to compute your function f or g, which is a composite function at 2, right? Because your function h here, this is the composite function of f and g. And then you know that by the chain rule, this is going to be f prime at g2 multiply g prime 2, right? This is a notation from the theory, right? So this is going to be f prime at gx times g prime x, right? So, and then after that, you look at the table that you have here. So g2 is g2, it's 3, right? So you have 3 here, and then multiply g prime 2. And then you're gonna have f prime of 3, which is 5, and then g prime of 2, which is 6, and then your answer gonna be 30. This question is simple, but you just need to, you need to be clear on the notation. So let's do one more. So I have p prime 0 here. So this is going to be g or f, right, at 0, which is going to be g prime of f0 multiply f prime 0. And this thing is going to be g prime at f0, which is 2, and f prime 0, which is -1. And this is 6 times -1, which is -6. Make sense? So I will leave this thing as your exercise. So I'm not going to show everything, but well, you can practice this thing at home. But the answer for this is going to be -20 and 2, just to check your work. But you should be able to do this thing easily. So try it. All right, so that's still basic question for the chain rule. Let's move to the medium one. All right, so before the move to the medium one, so we have learned that the chain rule, this is a form of the chain rule. If you have y is a function of u and u is a function of x, so you can use the chain rule by dy by dx, right, equal to dy by du multiply du by dx, right? This is the regular form of chain rule. So you can think that this is the same thing as you cancel du. So you have dy by dx. But what if you have more than 2 chains? So like you have y is a function of u is a function of v is a function of x. Can we use the chain rule? The answer is yes. If you want to use the chain rule to find dy by dx here, so what are you going to do here? You're going to do dy by du, multiply du by dv, and then dv by dx. So you can think of this thing like du cancel and dv cancel, right? So this is more than 1 chain, but it's still acceptable and valid. So keep in mind that if you have more than one chain, so you can do the chain rule as well. You just use the extended chain rule, right? Because you have more than one function, right? Because this thing on the right hand side that you see in the slide now, this is a composite function that you have f of g of h, like 3 functions in the same question. So let's move to the medium level example. So you're gonna see, you know, something that is more fun about the chain rule. All right, so let's do number 40 first. So find the equation of the tangent line that find the equation of the tangent line to the curve y equal to square root 6 minus square root 4 minus x minus plus x squared at the point 0, 2. So you want to find the equation of the tangent line, right? So do you remember how to find the equation of the tangent line? So this is our review. So some of you already forgot this thing. So I have to review first. So review. To find the line passing the point x naught, y naught, and having slope m, you can use y minus y naught equal to m times x minus x naught. So this is your basic geometry from your high school. So if you know that you have, if you want to find the equation of the line, right? You want to find the equation of the line that pass the point x naught, y naught, and you know the slope, which is equal to m. So the line, the equation of the line gonna be y minus y naught equal to m times x minus x naught. This is from the, you know, high school or something. You learn this thing since you get into the grade 9 or maybe grade 7 or something. So to find the equation of the tangent line here, we need to find the slope first. So if you want slope, so you need to compute the derivative, right? Because derivative is defined to be the slope of the tangent line. So that means I am going to compute the derivative of y with respect to x. So that means I have to take the derivative of this function. So I'm gonna say that my function here is going to be 6 minus square root 4 minus x plus x squared, everything raised to the 1/2. The reason why I do this because this is look easier for you in terms of find derivatives, right? Because you see the something inside parentheses raised to the 1/2 power, and then I am going to move 1/2 down, and then don't touch anything inside parentheses, right? And then you have 1/2 minus 1, and then you differentiate in the function. This is how you use the chain rule. All right. Sounds good. So the thing that I have here, I have 1/2 times 6 minus square root 4 minus x plus x squared, negative 1/2 here. And then I need to differentiate 6 minus that square root. So I differentiate 6, I get 0. I differentiate square root, that thing. So I simplify a little bit. So I don't like square root here. So I can do this thing as something raised to the 1/2 again. So I am going to have 1/2, and then I don't touch anything inside the parentheses, right? And then I have negative 1/2, and then I have to multiply. So d by dx. 1 second. I want to move this thing so I have more space. How can I scale this thing once. Okay, resize. All right, move it to this. So we have more space here. So, okay, so again, I have 4 minus x plus x squared raised to the 1/2. So when I differentiate that, so I get 1/2 times inner function raised to the minus 1/2, and then I have to differentiate 4 minus x plus x squared. Right? So you keep, this is like peeling your onion. You have to just do the outer function first, and then you just keep doing it, right? Just peel one at a time. And then I have 1/2 times 6 minus square root 4 minus x plus x squared raised to negative 1/2. And then here I have negative 1/2 4 minus x plus x squared raised to negative 1/2. And the final thing I have 0 minus 1 plus 2x. All right, done. Well, this is my dy by dx, but the thing that I want is the slope at the point x equal to 0, right? So I can plug in my number 0. So I have 1/2 times, so if I plug in 0, so I am going to have 6 minus square root 4, right? Raised to negative 1/2. And then I have negative 1/2 times 4 to the negative 1/2. And then multiply minus 1 plus just minus 1. All right, let's see what we have here. So I think you can compute this thing by yourself, but I will give the answer to you right away, which is 1/16. This is the remaining work is just, calculation. So once you just get, take square root and then simplify it, at the end, you're gonna get 1/2 multiplied 2 times. So, sorry, you have 1/2 multiplied together 4 times. So that means 1/16. So I have the slope. This is equal to 1/16. So which means the equation of the tangent line, this is going to be y minus 2 equal to m, which is 1/16. This is my slope. X minus x naught, which is 0. So for those of you who cannot follow me, so slope is 1/16, right? This is my m. The standard form is y minus y naught equal to m, x minus x naught, and then your slope m is here. And then your x naught, y naught, the point that the line is passing through is 0 and 2. So that means x not equal to 0 and y not equal to 2. And your answer is going to be the one that I highlight in green here. So y minus 2 equal to 1/16 times x minus 0. That's all for this question. All right, does it make sense? So this is, I would say this is the medium one. Well, so let's do one more example 41. So this is also the medium one, and then we can move to higher order derivative. All right, so this is also the medium one. Select. Ready? So we have the function y equal to f of x cubed minus 2x, and then x equal to 7t plus 2 over 6 minus t squared. I want you to find dy by dt, where t is equal to -1. And then I also have the condition that f prime 1 equal to 10. Well, some of you gonna say, after I read this question, I don't know where to start. Well, this is because you do not understand the notation clearly. So I told you that the hardest part of the chain rule is you need to understand the notation clearly. So what I want here, I want y dy by dt. So let's look at this thing first. So you have y is a function of x cubed minus 2x. Well, why don't we just define another variable so you can see this thing easily? So I'm gonna let my u to be x cubed minus 2x. If I let u to be this thing, then I have y equal to f of u, right? Which means now I have y is a function of u. And because I define u to be a function of x, so I have u to be a function of x. And then because x is equal to this thing that I boxed, so x is a function of t. So now you can see the chain. And then you can see that if I want dy by dt, I can use the chain rule to differentiate, right? And then you have to pass differentiate through the variable u and x. So which means if you want to use the chain rule, you're going to get dy by dt equal to dy by du first, multiply du by the x, and then dx by dt, right? This is a chain rule. But in the original question, the variable u is not given. You just construct it for the, to just make your work a lot easier, right? Otherwise, you have to keep your notation x cubed minus 2x, which is a bit hard. So let's look at this thing. How do you compute dy by du, right? I do not know, but I know that y is equal to fu. I mean, if I want dy by du, this is the same thing with f prime u, right? Because y is equal to fu, that means the name of the function is f. So dy by du is going to be f prime u. And then du by dx is going to be what? So du by dx, luckily you have u equal to x cubed minus 2x. So you can compute this thing easily. So du by dx is going to be 3x squared minus 2. Well, this is easy because you have u equal to x cubed minus 2x. And also the x by dt is easy because you have the fraction. So you can use the quotient rule again. Tedious, but it is doable. So I'm gonna have 6 minus t squared. I'm gonna go a little bit fast here. So I'm gonna do 6 minus t squared, and then I differentiate 7t plus 2 with respect to t. So I get 7, and then minus 7t plus 2, and then I differentiate 6 minus t squared, differentiate with respect to t. So I get negative 2t. All right, so after that I have this thing. So let's look at dy by dt at t equal to negative 1. So how do I find x when t equal to negative 1, right? Because when I have t equal to negative 1, so the one that I highlight in light blue, this is easy because I can plug in number 1. I can just plug in number 1 and that's it. But the one that you need to think a little bit, it is when you see x here, right? Because your x, what is your x when t equal to negative 1? So when t equal to negative 1, so your x is gonna be 7t plus 2 over 6 minus t squared, and then x is equal to 7 times minus 1 plus 2 over 6 minus negative 1 squared, and then you compute your x here, which is going to be negative 5 over 5, which is negative 1. So x is also equal to negative 1 as well. All right, so you have x equal to negative 1 and t equal to negative 1. So what is your u? So once you are, okay, I box it here. So once you have your t equal to negative 1, right? Your x equal to negative 1. Then, so your u is going to be x cube minus 2x, which is going to be a negative 1 cube minus 2 times negative 1. This is negative 1 plus 2, which is 1. So you use 1. So you plug in everything here. So you're gonna have f prime 1, and then multiply 3 times negative 1 square minus 2, right? And then multiply that thing here. Just lazy to copy that thing, but you can see that now your dy by dt, where t is equal to negative 1, this is going to be f prime 1. It is given, right? Because you know this is 10. It is given to be 10. So this is 10. And then 3 times negative 1 square minus 2, this is 1. And then that thing, you can compute it. So I will leave it as your, well, I can compute it here. So let's compute it. So on the numerator, I plug in t equal to negative 1. So I am going to have 25. And then on the top, 5 multiply 7, which is 35. And then minus, so t is negative 1. So that is negative 7 plus 2, which is negative 5, times 2, which is negative 10. And then negative 10 here. So that means you're going to have 45 over 25. Well, after you compute everything, so it's going to end up with 18. You cancel everything, you have 18. So this is your answer, 18. So you can see that, well, the hardest part for this question is you have to set up the chain rule problem by letting u to be x cubed minus 2x. So you can see the problem easier. All right, and that is all about the chain rule. So in the chat, everyone here, so give the point about your understanding on chain rule. Out of 10, what would you give to yourself? Go ahead and type the score that you give it to yourself about the chain rule. Well, let's say if I give you a problem about the chain rule, how confident you are that you can do the chain rule problems. So type in the chat, out of 10, what do you think? Does not exist. All right, most of you are gonna say 7 or 8 because you're not that confident, right? So I would say you still have time because this is the first class on chain rule, but once you keep doing it, so you're gonna get better and better. But listen to me, chain rule is the easy one. When you do the exam, chain rule is the easy one. You should do chain rule first because chain rule is the easy topic. So differentiation is the easy one because you know the formula and then you can differentiate it. All right, so I look at the chat now. So most people are gonna say 7, 8, 7, 8. Okay. Well, that makes sense. All right, so we're gonna move to another topic, which is higher order derivative. So I think, well, I will not give you a break because we can just keep continuing our lecture and then we're gonna leave early. That's maybe better for you. So we're gonna keep going on higher order derivative and then maybe we're gonna leave 5 to 10 minutes early. All right, so let's look at the higher order derivative here. So one more, I would say one more topic for today and then we're done. So higher order derivative is not hard, but the concept is not hard, but it could be hard sometimes when we ask you to do the general, the n order derivative. So first, let's look at the definition first. So we have know that if I give you a function f, the derivative of f is still a function, right? Let's say I have fx equal to 6x to the fourth power minus 5x. Well, if you differentiate that, so you're gonna get 24x cubed plus 5. Here, this is still a function. So which means you can differentiate more. If you do that, this thing is called higher order derivative. And let's say if you do it one more time, so this thing going to call second derivative of f. So if I say the second derivative of f, that means I differentiate f 2 times. So the notation gonna be f double prime x, like that, or dy by dx, but because I want to do it 2 times, so I'm gonna say this is d square y by dx square. This is just our notation for the second order derivative, or just second derivative in short. Right. This is just our notation. So if you see this notation and this notation, that's mean the second order derivative. There's nothing complicated more than differentiate one more time. In general, if you differentiate, keep going n times, so you're gonna have f raised to the n power. Oh no, sorry, the n order derivative. I should say this is n order derivative of f, right? This is our notation. Make sense? So let's compute the n derivative of the function f in example 42. So if I have the function here, so I can differentiate this thing n times, right? So first I can differentiate the first time. This is 3x squared minus 4x plus 4. This is just differentiate one time using the formula. And then differentiate 2 times the second derivative, 6x minus 4. Sounds good? Third time, 6. The fourth time. So you can see that after the third time, I'm not going to use the notation prime. So after the third one, we're going to use f and then raised to the parenthesis 4. This is our notation after the third time. This notation not popular. It is not popular to use prime after the third derivative. So after starting from the fourth one, we're gonna use parentheses and then number. So this is going to be 0. And then, well, because that differentiate constant, you always get 0, right? So you're gonna keep going, you keep getting 0, right? Well, which means f raised to the parenthesis n, which is the differentiation at the n order. This is going to be 0 for all x is greater, for all n greater than or equal to 4, right? Which means, yeah, after n equal to 4, everything must be 0, right? But for 1, 2, 3, you have the answer here. Sounds good? All right, this is called higher order derivative. However, the problem that you could see on the exam is the one that we want you to find the n order derivative in general. So let's look at example 43 and 44. This is the same level of the O exams, and it is very likely that you're gonna see it again this year because, well, we keep repeating this problem again and again and again. All right, so that will be our last 2 examples for today as well. So let's do 43 and 44 for today. All right, number 43. So I want you to find the n derivative of f, which is this function 1 over 2 plus 3x for all positive integer n. All right, how would you do this thing? So let's start by simplify this thing a little bit. So I have fx equal to 1 over 2 plus 3x, right? So I'm going to simplify it to 2 plus 3x raised to the negative 1, right? I do this because this is going to be a lot easier to differentiate if I simplify to this form, right? And then let's start by f from x. So you're going to get negative 1, 2 plus 3x raised to the negative 2, right? Because negative 1 minus 1, this is negative 2, right? And then you have to differentiate inner function, which is going to be 3. Sounds good? Well, for those of you who cannot follow me, so I do negative 1, 2 plus 3x, negative 1 minus 1, and then I attach d by dx 2 plus 3x, right? Because I have to differentiate inner function, and then differentiate inner function, I get 3. So that's why from here, I go a little bit faster to this, and everyone should do this pace on the exam. Just you don't have to say the thing that I write in green all the time, because this is going to be too slow. If you do that thing, the thing that I wrote in green all the time, on the exam you only have 3 hours, and then you cannot complete it all because you are going too slow. So, well, once you get more comfortable with the chain rule, you can just do the same thing as I did in red. So I just use the chain rule, and then I differentiate 2 plus 3x, and then I get 3. So, and then after that, so you can see now that this thing is constant, right? Negative 1, and number 3 is constant. So the thing that you have to differentiate is this. So we are going to do f double prime. So I keep negative 1 here, don't touch it. And then I differentiate 2 plus 3x raised to the negative 2. I have negative 2. 2 plus 3x to the negative 3. Right? Because I need to use the chain rule. And then I have 3 attached one more time. So the thing that I do the parenthesis in green now, this is obtained by I differentiate 2 plus 3x raised to the negative 2, right? I differentiate that thing, so I get negative 2 times 2 plus 3x raised to the negative 3 times 3. All right, and then I keep going. One more time, so I have f triple prime, and then I am not going to touch negative 1, negative 2, just keep it like that. And then I have to differentiate 2 plus 3x to the negative 3. So that's mean negative 3. 2 plus 3x raised to the negative 4. Right? And then I have 3. One more 3 attached here because you use the chain rule. Well, the pattern keep going, right? What is your n derivative, n order derivative here? This is what you have to answer. All right, and usually we ask you to do this on the exam. So, well, in order to prove this thing formally, if you want to prove this thing formally, you can do that by using mathematical induction. You can prove this thing formally by using mathematical induction, which we are going to learn in Calculus 2 next semester. But this semester, we want you to guess the answer first. What is the n order derivative of f? So look at the pattern. So you have negative 1 here, negative 2, and negative 3. right? If you differentiate up to the n order, you should get -1, -2, -3, up to -n, right? And then your 2 plus 3x to the -4 here. So if you can see that if you differentiate 1 time, you get 2 plus 3x less to the -2. 2 times, you get 2 plus 3x less to the -3. So which means n times, you should get 2 plus 3x to the -n plus 1, right? So I just highlight the one in light blue. That is the pattern, the first pattern. The second pattern that I highlight in green is that. And the last one, you can see that I have 3 here. And then I have 3 multiplied 2 times, 3 multiplied 3 times. So which means for sure, well, up to the n order, I need 3 n times. So which means my n order derivative, this should be what? Well, make the notation more simple. How would you do it? So what is 1 times 2 times 3 up to the n? So what is the notation that we usually use? Anyone know that thing? Type in the chat. 1 times 2, yeah. Someone said factorial, yes. So if you multiply n times, so you're gonna have n factorial, but you have negative sign with you as well. So it's -1 raised to the n power times n factorial. And then, well, I have 3 multiply n times, right? I have 3 to the n. And then I am going to move my 2 plus 3x to the denominator. Well, this is the complete answer. Well, if you can answer this thing, 10 points. Make sense? Well, and this is, usually this is a candidate for the midterm exam. Usually when we ask you for the higher order derivative, usually we ask you to do this. So you should be able to do something like this. Make sense? So we're gonna practice one more, example 44. All right, so make sure you can do this thing. So let's do example 44. All right, so I think this could be the last one for today, and then we're gonna talk about the plan next week. So example 44, well, also all exams, you can see that we ask you to do this all the time. All right, so fx equal to 1 over 5x minus 1 square. All right, so again, I will do the same thing as the previous question. I am going to simplify first to 5x minus 1 less to -2, because this is a lot easier to figure out the pattern. So, well, this is f prime x, which is -2 times 5x minus 1 to the -3 and 5, right? Easy now, because f double prime x, so -2 times -3. Yeah, the problem looks similar to the last one. Too easy. 5 and 5, right? Am I going too fast? Just, you know, 2 and -2 is just constant. I don't touch it. And 5 is a constant. I don't touch it at all. So I only differentiate 5x minus 1 to the -3. And then I keep doing that. -2, -3, -4. All right. So you can see the pattern now. -5 and then 5, 5 and 5. All right. So what is going to be our n order derivative? So for sure, it's going to be -2, -3, -4, up to -n plus 1, right? So let's talk about this thing first. So the one that I highlight in yellow, it matches with the pattern, right? If you do the second derivative, you have to multiply up to -3. So the n order derivative, you have to multiply up to the -n minus 1, right? And then the middle term here that I just highlight in blue. So that thing is going to be 5x minus 1 raised to the negative n plus 2, right? All right, and the last one that I just changed the color in green now. So whoop, that is easy because that is going to be 5 to the n power, right? Because it's 5n times. So simplify a little bit. So you're gonna have negative 1 to the n plus 1 factorial. Can you follow me? So 2 multiply 3 multiply 4 up to n plus 1. This is n plus 1 factorial because, well, I include 1 as well because, you know, 1 multiply anything is that number, right? So that means I can include 1 as well. So it's actually 1 multiply up to n plus 1. So this is n plus 1 factorial. And then because I have negative sign n times, so I have negative 1 to the n. And then I also have 5 to the n, and then 5x minus 1 raised to the n plus 2 for all n. All right, this is your answer. Another pattern that you should do, the n order derivative is going to be trigonometric function. For next week, you're gonna learn, well, for next week, the plan for next week, what are we going to learn is we are going to start by learning the implicit differentiation. And then after that, we're gonna learn the derivative of trig function, trigonometric function, and also inverse trigonometric function. Raise your hand if you know that you are weak in trigonometric function. Well, you can type in the chat that if you are worried about trigonometric function, because next week we're gonna start doing trigonometric function, and usually students have a hard time about trig and inverse trig, but next week we're gonna look at how to differentiate sine, cosine, tangent, and so on, and arc sine, arc cos, arc tan, something like that. So